I am Simran Singh, registration number 18BEC2032. I have finished this assignment for the course Computer Organization and Architecture under the guidance of Professor Dhanbal R. This assignment asks us to analyze a floating point unit from open access journal using the concepts learned in the syllabus. I have utilized the online drawing tool called Da2 for making the block diagrams and architecture diagrams for this assignment. I hereby illustrate this drawing tool. The given diagram, for example, was created using the drawing tools, the general drawing tools as shown here. Further, these drawing tools, these and blocks were edited using these options. Coming to the assignment, the research paper which I have referred is called the Floating Point Unit for Signal Processing Applications. This research paper was published by IEEE in the year 2016 in the month of November. It was published in the Online International Conference on Green Engineering and Technologies. The first question expected us to explain how the selected paper is related to the syllabus or the curriculum. At first, I have explained what is a floating point unit and how it is necessary, and what are the important characteristics of the FPU. The operation carried by FPU can be trigonometric, logarithmic, scientific, and basic floating point functions. Further, I have explained the IEEE representation of floating point numbers. Again, the representation is explained with the help of three parts: the sign, the exponent, and the significand. Thus, this correctly explains how the FPU is a necessary part of any control system or control unit. The second question asks us to explain the existing architecture discussed in the paper. The following diagram explains the architecture discussed in the paper. The main subunits are, as seen in the diagram, 3:8 decoder, pre-normalization, post-normalization, addition unit, subtraction unit, division unit, the square root and inverse square root unit. This architecture correctly explains what happens and how the floating point operation happens when two operands A and B undergo the operation. The next question asks us to tabulate the results and the graphs obtained due to these architectures. The basic two architectures which were mainly discussed in the paper are the DEVA and the Monarch architecture. Further, the area implementation of these architectures can be seen in the given diagram. It can be seen that DEVA has a smaller design for the same time constraint used due to less logic per stage. Further, the table compares the DEVA FPU and the Monarch FPU on the basis of technology, supply voltage, dimension, gate count, transistor count, and speed. The number of transistors, as it can be seen, is more in the Monarch FPU. The given graph explains the power dissipation and compares the power dissipation of both DEVA and Monarch FPU. The next question asks us to give the detailed architecture of the proposed architectures in the paper. The DEVA FPU, or the data-intensive architecture, is a 5-stage pipeline architecture. Following is a diagram which was drawn using the tool Da2 in order to explain the architecture. The main subunits, as you can see, are the exponent data path, ALU fraction data path, and multiplication or division fraction data path. A and B are the two operands which undergo the operand formatter first. The result undergoes the rounding logic and the formatter and exception generator to get final output. The movable network microarchitecture, or the Monarch FPU, on the other hand, is a 3-stage pipeline architecture. The following diagram explains the Monarch architecture. It again also has operand formatter, the data paths, the rounding logic units, and result formatter units, but is a three-staged pipeline structure. The next question asked us to draw the transistor level internal diagrams using electronic schematic capture. Both DIVA and Monarch have 0.18 micrometer CMOS technology. The following diagrams explain this in detail. Coming to the next question, it asks us to compare these architectures proposed by the selected paper with the existing architecture in our book. A comparison between the old floating point architectures and the recent architectures is made. Furthermore, how the proposed floating point units are now targeting more applications is also explained. The pipelines of the new proposed architectures is explained with the following diagrams. A comparison between the given architecture is also made. The next question asks us to list the advantage of the proposed architecture. The main advantages which were of the proposed architectures in the selected paper was the high performance of these FPU units when compared to the older ones, as well as they were highly area efficient. They were of low cost, wider range of precision, and power and area reduction as well. They were able to carry operations parallelly and had a higher speed. The eighth question asks us to list the merits and demerits of the proposed architecture. The merits, as explained in the previous questions, were the high performance, lower cost, reduction in delay, wider range of precision, and programmable. The demerits, when discussed, came out to be their complex design, only single precision, increase in area according to the operation, and the requirement of a large number of tests during the construction of the floating point unit. The next question asks us to list the application of the proposed unit. The paper which I have selected mainly focuses on the design of the floating point units for high-speed signal processing. This is the required need because nowadays engineers handle a large amount of digital data which require fast calculation as well as computation. Further, FPUs are of great need in the fields of geography, astronomy, and biomedical engineering. Apart from digital signal processing, data acquisition, as well as image compression, where multiplication and addition operations are frequently required, also highly depend on the use of floating point unit. The fields which require the computation and calculations of mass data, such as banking and finance, also highly exploit the FPU. Thus, these were the applications of the floating point unit as discussed in the paper. The last question asks us to show the flowchart or algorithm of the operations. The first flowchart is of the addition and the subtraction algorithm in the floating point unit. It shows how when operands undergo addition and subtraction. The next flowchart is of the multiplication algorithm in the floating point unit. The last flowchart, which was drawn, explains the division algorithm in the floating point unit. The reference used for this assignment is the research paper The Floating Point Unit Core for Signal Processing. This paper first gives us an insight into the floating point unit and the applications. Then it proposes few important floating point units. such as Diva and Monarch. The fused arithmetic unit is also discussed with the help of this diagram. Furthermore, lightweight floating point arithmetic unit is also discussed. The Wallace tree, which is again an important FU, is also discussed in the selected paper. The block diagrams and the algorithms can also be seen in the paper. At last, the paper is summarized with the advantages, limitations, methods, parameters of the selected architectures, of the proposed architectures. And then the paper is concluded by mentioning the different methods of floating point units. Hence, this assignment was successfully completed under the guidance of my professor and with the reference of this research paper. Thank you.